Hello, everybody. How are we doing? So, today we are going to talk about smell and taste. So, we're continuing with our special senses here. Smell and taste are unique, and I put them together because they are both chemical. So, they chemicals that are binding to receptors and eliciting a response. So, what we're going to talk about today. So, we're going to describe the structures responsible for the special senses of taste and smell. And then we're going to distinguish how different tastes are transduced. So, how we send these taste signals from our taste buds that you probably heard of to our brain. And also, and what goes hand in hand with this is also smell. It's a similar sort of process for each of them. So, first up here, we have gustation. Gustation, or your gustatory area is of the region of the brain, is referring to taste. Now, as we know, we have five general taste senses. So first up is sweet. This is sugars, so our monosaccharides, our glucose, our fructose, and so forth. Binding monosaccharide carbohydrates and eliciting that sweet taste to go with them. Salty. Salty, sodium chloride is the big one here. So Na plus binding to sodium receptors and allowing sodium to come in and depolarize that cell. Next up, we have sour. Sour is typically referring to something that's acidic and so has hydrogen ions in it. So typically, sour and bitter here are supposed to be things we don't eat. So think for taste, think about why we evolved these particular senses back before we had proper food storage and things like that. If something was rancid or going bad, it would become sour. So you would know to then spit it out. Same thing here with bitter. Bitter, I here have all my alkaloids. So when something becomes bitter or spoiled, so it has these alkaloid structure. Aspirin is actually an alkaloid. And those taste buds are further in the back of the mouth. So when you taste something bitter, it initiates a gag reflex so you can reflexively vomit it up. Now we do drink certain bitter things. Black coffee, for example, double IPAs, wine, all of those are quite bitter. But usually we mix things with something sweet. So beer has all the carbohydrates in it, so it gives a sweetness to it. Coffee, usually add cream and sugar and all of that. So you add that little bit of sweetness to battle that bitterness. Now, some people really like bitter drinks and things like that, so be it. But think about why we have these taste receptors for sour and bitter. Then the last one here is known as umami. Umami is a savory flavor, and it's from an amino acid called glutamate, which is found in meats and cheeses. You might have heard of MSG. MSG stands for monosodium glutamate. So it's just a glutamate with a sodium ion. Besides that, it's just an amino acid. The reason it gets a bad rep is because it increases the amount of sodium you're bringing in. And some people say they get headaches when they eat food high in MSG. It's because it's messing with your blood pressure. If you eat any foods high in sodium, it could cause those sorts of situations. So MSG gets, we talk about MSG in a bad way sometimes because of how much sodium it adds to our foods. But the glutamate itself is initiating that savory sensation and making that food taste just a little bit better. So let's look at the tongue here. So we have different regions of the tongue, and when we think about the taste buds, you think of them as the bumps on your tongue. Those are not taste buds. Those are just the papilla. So here, there are different ones. You don't have to know all of the various ones here, but there's the fungiform papilla, the filiform papilla, the foliate papilla back here, the circumvallate or the vallate papilla are back here. So we have all these different papillae. And the purpose of these papillae, so they just all have some slightly different structures to them, is that they have these crevasses in them. You see these little parts that come down. And then within those parts, that's then where we have the taste buds. So you have tons of taste buds. If we zoom in to this image right here, this is like the max zoom we can get. This is what one of those little, crevasses look like. And then actually you can kind of see the outline of one right here. There's one. Here's another one. So right there are actual taste buds. So the whatever you're tasting comes in, say it's salty and it's a salty ion, comes in and there's the taste pore, and then comes in, binds to gustatory cells in here that then activate neurons down here and then would send the signal out if that was for sweet. So that's what the taste buds are. So the taste buds are different than the papillae. So here they would bind to these gustatory hair cells here, elicit a response, and that then activates these neurons. Remember we didn't really go over the cranial nerves, but you have 3 nerves that are cranial nerves that send the signal of taste to your brain. So it's not all one same nerve that does that. All right, let's move back over here. So next up we have smell. So that's taste. Now another one thing for taste that, oh no, my mic was way up here the whole time. It's okay. You might have been able to hear me. It's only been 6 minutes. Sorry, I never brought my mic back down. Alrighty, so another thing with taste is your joyness of spicy food. Spicy food doesn't have a taste here. So how do you enjoy spice? Well, spice is actually capsaicin binding to nociceptors. Nociceptors are pain receptors. So your enjoyment of spice is your enjoyment of pain inside your mouth. Kind of. Pain is all about perception. So we're all firing the same pain stimuli. So the same amount of action potentials are going to our brain. It's how we perceive that. So if you grow up eating a lot more spicy food, you perceive that differently than someone who's eating a bland diet all their life. And of course, we all have different enjoyments and not enjoyments when it comes to eating different foods. Alrighty, again, apologize for the mic if the first part of this was a little quiet and then all of a sudden it got loud on you. All right, so next up is olfaction. Olfaction here is smell. So for smell, of course, it all occurs in the nasal cavity. So inhale, it has to be a chemical that you inhale, comes in, and then once it gets up to the roof of your nasal cavity, that's where it interacts with your olfactory epithelium. So there's a layer of mucus found in there, and the smell chemical, oops, what's it doing? Let me zoom back in here. It was jumping on me. Whatever you're breathing in will bind to these olfactory receptors, smell receptors here. So these are olfactory receptors. And then, so this is a olfactory gland producing the mucus that's out here. And then they travel up, this one binds, travels up, sends that signal up through the ethmoid bone. There's all these little holes called the cribriform foramina. This is your cribriform plate. And then they communicate with olfactory neurons here, known as mitral cells. They form these little tufts of, look like ball of yarn called glomeruli, and then interact with these mitral cells and then send a signal out the olfactory tract. So you can smell thousands of different things. We have a pretty good sense of smell. Some animals like dogs have an even better sense of smell. So why is that? Well, we have about 400 smell genes. So that's 400 receptors down here that can bind to different things. Now, they can bind at different intensities, and let's say one particular smell, let's pretend we're smelling strawberries. That strawberry smell is made up of hundreds of different possible chemicals that are in the air that the strawberry is releasing. And all of them will bind to different receptors. And let's say you bind to 10 of those 400 receptors. Those 10 are what elicit a strawberry smell. So you can kind of see how those 400 receptors could vary all the different smells by binding different combinations of them and so forth. Imagine an alphabet of 400 letters, and you could choose a random amount every single time. And that equals something else. So 400 different combinations and so forth. And that's how we can smell so many different things. Now,
These olfactory cells, there's also stem cells that are supporting them here. So these olfactory cilia, stem cells that give rise to new olfactory receptor cells here. So this is a unique one here where there are stem cells that give rise to new smell cells. But overall, that's in essence what smell is. Both of these are chemically gated receptors that bind. So here's what that olfactory epithelium looks like. It's a little harder to tell what everything is here, but you can see the mitral, not the mitral cell, but the smell receptors down here in the olfactory epithelia here. And here's where it's binding the smell. And then here's the mucus secreting cells here. Again, you don't have to understand how to break down histology image. And then what you can't see is how they're traveling then up through there. You can't see the axons moving up through, but you just have to trust me that they are there. Alrighty, so quick little video here going over the special senses in terms of smell and taste. Again, these are both chemical senses, and they go hand in hand. So your enjoyment of food is mostly smell. So you smell that food first. We've all been sick before. Food tastes bland. So the likeness of food and something that tastes good also has a good smell to it. And also for enjoyment of food, texture plays a role too. Like cottage cheese is just horrible. And and you're drinking wine, you'd give the red wine a swirl or whatever, so the aromas come up and sit in the top of the glass, so that when you take that sip, and with your pinky out, of course, your nose goes in and gets the aromas of whatever that wine is. And so that's why different glassware exists for different sorts of drinks. So that's the chemical senses right here, and kind of cool. And one big thing that people don't get right away is that your little bumps on your tongue are not your taste buds. The taste buds are actually down in little fissures, pretty much, within the papillae on where the taste buds actually are. There are also stem cells found in here. These gustatory cells are also stem cells that can give rise to new cells. So yeah, that is the little overview here of smell and taste. And like always, if you have questions, just let me know and I'll address them. All right, have a great day. Bye bye.